That's good. Thank you. So, hello. My name is Ayoub Alouane. I'm CTO Academy at Adservio. I'm Moroccan, but I'm coming from Paris. I'm working here in Europe. It's my third year here. And today, I will talk about web performance and more precisely about the African case. So the first question, why? OK, so we'll get the answer after. So to start with the African context here, I have a graph that shows the internet penetration rate by region. Here, for example, we have the south of Africa. It's good. They are doing good. We have north of Africa, the same thing. It's the same statistics as Europe. And we have the world average is, I think, 70% of penetration rate. But we have the middle of Africa and the east of Africa that has, it's okay? What? Okay, sorry. It's my beard. I should shave it. Okay, it's working now? Good? Great, okay. So we have here the world average is 70%, I think, of penetration rate, and we have the middle of Africa and eastern of Africa that are less than 35%. So the question here is why I'm talking about that. The answer is very simple. It's because when we have a good penetration rate, for example, we have fiber optic, so we can consume an limited data, limited internet. But if we don't have a good penetration rate there, people should buy data. So they should pay for what they consume. So they will mostly use mobile data and not fiber optic, for example. Here we have also another statistics for the most devices used in Africa. So here we have, for example, 23% of laptops, but 75% of mobile phones. So that's so normal because if someone is in the work or in school, they in the middle of Africa or in the east of Africa, mostly are poor countries, so they don't have access to laptops, for example, so they will use mobile phones. And when I'm talking about mobile phones, I'm not talking about iPhones, okay? So here, for example, I have another stats that show the price for 15 gigabytes per month of internet. So when I'm talking about 15 gigabytes of internet, I'm talking about someone who will watch 1 hour video of YouTube each day for 1 hour with the quality of 480p, okay? So if you watch 1 hour per day in YouTube with the quality of 480p, you will consume in a month 15 gigabytes of internet. Here we have the price of 15 gigabytes of internet and also the minimum wage. If you see, for example, Benin here, you will find that the price for 15 gigabytes of internet, the minimum wage is 2 times the price for 15 gigabytes of internet. Okay, so if he wants to watch a video of YouTube per day, he should waste 50% of his salary. Okay, that's not good. So the question here is why I'm talking about this. What does that have with web performance? We will see. Stay with me. Here, for example, we have a country like Zimbabwe that has the price for 15 gigabytes of internet is 4 times the minimum wage. Okay, so imagine you're using SPA, an Angular, for example, and when the guy clicks on the website, he should download 30 megabytes of JavaScript. And you didn't do the optimization of images. Each image is 5 mega. So maybe you will consume more all the salary of the month if you didn't do these optimizations, okay? So if you are leveraging something to the client that he will not use, you will consume his data. And that's a problem because if you are in some countries of Europe using 5G or you have a good internet, you will not care about that. But for others, it's not the same thing. And in here, I'm not talking about Africa. It's the same thing in some countries in Asia, some countries in Southern America. It's the same thing. Here, I did only studies for the African case, okay? And here I have phones, for example. And why I'm talking about phones? Because People, if they need to access the websites that you did, they will use mostly phones. And like I said, not iPhones. So they will use phones like Techno, like affordable phones like Etel, that doesn't have more than, for example, 2 GB of RAM. So they don't have good resources to access the website. So imagine that you leverage 30 megabytes of JavaScript and you execute all this JavaScript. You will consume a lot of RAM for him, and that's not good, okay? So here I will talk about another thing. Imagine that we are cool, we have access to internet, we don't care, but there is something called Google. They have robots that go to your websites and check for the performance of your website, okay? What is that? So here, I told Dali here, please, I want an image of a Moroccan guy waiting for a couscous. And that's what it generates for me. And where is the couscous? Here is the couscous. Who knows already the couscous? So this is the original one. By the original one, I mean the Moroccan one, okay? That's the Moroccan couscous. So imagine that you are in a restaurant waiting for Moroccan couscous, but the waiter told you that you should wait 45 minutes for that, and you will pay 200 euro. That's too much time and money, okay? But near him, you will have another restaurant that will give you the same couscous with the same quality with the price of 10 euros, okay? And you will wait only 10 minutes. You will choose the other one, of course. And you will do what for the first? You will write bad reviews in Google. You will tell your friends they should never come to this restaurant. Maybe you will stay for 45 minutes, but when you will leave, you will never come back. And that's a problem. And that's what we call the user experience. That's the same thing in restaurants and in your websites. So if you don't have a good user experience on your websites, for example, you're using an SPA that, and the client should wait for 10 seconds to download all the JavaScripts and the images that you didn't optimize, that's not a good user experience. And Google are using some metrics to measure that, okay? So the first metric here that we have is largest contentful page. So what is largest contentful page? It's a metric that Google use to measure the largest element of your page. If you have, for example, an image, it will measure the time that will take this image to show up in your page. If it will take more than 4 seconds, you will have a bad score. And that will impact the ranking of your website in Google search. Okay? We have a second one here, CLS. So what is CLS? Very simple. I will show you. I have here the page of Financial Times. You come to the page, you want to click on sign in, you're so excited, and you click on the ad. That's what happened mostly. That's a problem. That's what we call CLS, cumulative layout shift. So Google are using this metric to measure how many elements you have in your page that move a lot. So that's not a good user experience also. Here we have the first input delay. So what is the first input delay? The first input delay, it's a metric that measures the time between an element is visible and it's interactive. Sometimes you have a button, you click on the button, it doesn't work. But after 2-3 seconds, it works. Great, why? Because the button doesn't have the JavaScript yet. It was waiting for the JavaScript to be downloaded and executed. And Google are using this metric to measure the time between this element, for example, is in the page and when it's interactive. If it took more than 300 milliseconds, that's not a good user experience, and that will impact your ranking in Google search. Okay, here we know we are in a capitalist world. Okay, so we care about the conversion rate. Here, Google did some researches, for example, for the website's Cook, that they improved their performance of 850 milliseconds, and they got 7% of more conversion, okay? We have also Mobify here that improved their websites with 100 milliseconds, only milliseconds, it's not seconds, it's only 100 milliseconds, and they had 1% more conversion. That's why we should care about web performance, because we have users there that doesn't have a good access to internet and good resources to use internet. The second thing, we have something called Google that has some metrics that measure our websites, and it will impact our ranking. And the third thing, we should sell more. Okay? So here I will talk about the web evolution, because here I'm talking only about the problems that we face. But why? The question is why we are facing these problems. So I will start with single-page application. I'm sure that most of you worked with already with React, Angular, and this framework started as simple SPA, single-page application framework. So how single-page application framework works? It's very easy. The first thing that they do is they send what? A blank HTML file that contains nothing, only the ID root, okay? And when they send that, the client, what he will see only a simple page, a blank page, okay? After 5 seconds or more, he should wait to download the bundle of JavaScript, okay? And after that, he should wait also to execute this bundle of JavaScript. And after that, we can do the rendering, and we will have our page working fine, okay? So we said that that's not a good user experience. If you think about that, you will have bad scores in Core Web Vitals, okay? So they tried to improve that. For example, if you're using Angular, they did something called Angular Universal to have SSR. So, for example, to have this process of, to improve this process of single-page application of the rendering, we used something called hydration. So the question here is how hydration works. Very simple. We send the HTML, but it's not like the first one. It's not blank HTML, but it contains all the information that we should display in our page, okay? So we will show something to the client. The client will be happy, but where is the JavaScript? It appears faster, of course, but he should wait for the JavaScript. He should execute the JavaScript. And after that, he will do the process of hydration or reconciliation of this JavaScript. So the difference here is that, for example, Angular Universal first started with what? When they send this HTML, they send it to the DOM of your browser, for example. But when they send the JS, the JavaScript, and they execute it, they remove the first DOM and they install the second one. So they improve this process. Now they use reconciliation. They keep the first DOM, and they try to sprinkle some JavaScripts in the DOM of your browser, okay? That's how it works now. That's good. But for example, here with the metric of FID, you will not have a good score because you will have some buttons that are shown up to the client, but it should wait for the JavaScript to be executed. So today I will talk about what? I will talk about, I have a slide before that. So here's a slide that shows the correlation between two things, between the amount of JavaScript that we execute in our page and the performance of our websites. Imagine that you have a website that the user demands a lot of interactivity. I want this button, I want another button, I want graphs, I want these things, a lot of things that he wants. And if you're working with SPA, you will send a lot of JavaScript to the client. Okay, so he should execute all this JavaScript. This will impact the performance of the website. If you are using a little bit of JavaScript, this will not impact it, but the more you use JavaScript, the more you need interactivity, the more you will have bad performance. So how we can improve that? Today, I will talk about something called resumability. So what is resumability? I will present first how it works. First, like before, we send an HTML, we show the page, and after that, the page is interactive. You can interact with the page. The question is how? We will never use JavaScript. It's only about HTML. No, it's not the case. So Here, resumability is used by a framework called Quick. So what is Quick? It's a framework was done by the creator of Angular, it's Evry Mishko, and he did another framework. He did the first framework, AngularJS, for the SPA, and he saw that there's a problem there, and now he tried to fix the problem that he did with SPA, okay? And with the framework called Quick, you can use the resumability. So how it works? The first HTML that we send, it contains a little bit of JavaScript that we call the global listener. It's 1 kilobyte of JavaScript that listen to all the interactions of your user. Okay? And if the user, for example, interact with this button, it will go and search for the small JavaScript needed only for this button. If he interacts with this one, he will go and search for the JavaScript needed for this one. It's clear? The problem here is that we don't have one bundle JavaScript. We have multiple chunks of JavaScript by interactions. Okay, for each interaction that the user needs to do, he will have JavaScript for that. How it works? I will have a demo for that. So imagine that we use this paradigm of resumability here. That will impact a lot our graph, okay? So imagine that we have a lot of JavaScript, but we don't need to execute all of this JavaScript. We will execute only what the user wants. With that, we can scale our app, okay? Because the user will only execute what he needs, not all what is shown to him. So I have 13 minutes. I will start my demo, okay? So that's the moment of vérité, because I will start coding now, and I hope it will work. I don't know if you can see that. That's good? Great. So, like you can see, this is Quick. It's a simple framework. If you do React, you can do Quick. You will not have a curve of learning. You will not need to go search for courses, buy courses. No, it's not the case. If you're using already React, you can use Quick. It's not the same framework. It's another framework, but it's using also J6. Okay? So here I will start with, I will show you. Here we have, for example, routes. We can come here and create a route for JSConf Budapest and index.j6. So I will start simple here. I will create a simple component. That's simple J6. There is a small difference here is this $sign, money. I think you should pay money for each component. No, I'm just kidding. You will not pay money for that. So here I will have a simple component that we will have hello quick. That's good. And so what I should do now, I don't remember my demo. So no, I remember. Okay, I will have a simple button that we will call GS Budapest. Okay? So what this button will do? Simple thing. It will do simple on-click. Also, the on-click is with $. So for every interaction that the user will need to do, he will need to pay money for it. Okay? We have here a $sign. So come here, and I will tell him, do a cancel log. You should pay for that. So here, Budapest. That's good. Sorry. No, I can't see it. That's good. It's working good. OK, I will see. So here, when I will refresh my page, here I have only CSS, HTML, simple thing, and I will search for my JS. Where is my JavaScript code? But here I use JavaScript. I have an on-click, I have a cancel log, so I need a JS file for that. Okay? So the button should work. If it should work, the button will need JavaScript. Okay? So here I did only a simple cancel log because I don't have time to code all an app. What you can imagine is that behind every button, there is a lot of code to JavaScript, and a lot of code is a cancel log in my demo. Okay? So I don't have a file here. I didn't download anything. And the button should do what? It should cancel Budapest. When I will click on JS Budapest, it will get a button for only this interaction, and I will have Budapest here. So imagine I will have 2 buttons here, okay? So I will say here Morocco, and here JS Morocco. We will have JS Morocco next year, okay? Great. Here I have 2 buttons. I will click on network. I don't have JavaScript. When I will click on JS Budapest, I will get the JavaScript needed only for this button. And when I will click on JS Morocco, what I will get, you can see with me, I will get the second JavaScript needed for this interaction, okay? And I will get my console log. Imagine that you have multiple buttons, a lot of data tables, a lot of graphs. You will not have this JavaScript in your page until the client interacts with your page. Here, the first question that you will ask. Every time we need an interaction in our page, we should go to the server to get this JS file needed for this interaction. That's a lot of time we should wait. Every time we send a request, that's not a good thing to do. Okay, I see. It doesn't work like that. It's more simple than that. Okay, so to avoid this latency, when you're using SPA, when you're using single page application, that's the concept. You will get all the JS needed for your website. That's good, okay. If you're using Resumability, first you will get the JS files needed for your page that you show to the client, not all the websites. But where is this JavaScript? I don't see it here. Quick is using something called service worker. That is what it does. When the client click on your website, it will start downloading all the chunks needed for the page that you will show, and it stores them in the cache. It will execute nothing on your page. So the cost of executing the JavaScript will not be there because you will execute nothing. Here, there is 2 things. There is the download of JavaScript and the execution of JavaScript. You will execute nothing, and you will download only the JS files needed for the page that you show to the client. Okay? That's good. Imagine we have another things. I have here a clock. What I will show you here is magic. So it's a clock, but what's the thing about this clock is that I will show you. I need to show this clock when I get to the page. Here there is a problem. The clock needs JavaScript to work. So when I will refresh my page, I will get JavaScript because the clock should work when the client accesses the page. Okay? I can't do nothing about that. I have this JavaScript needed for the clock, and here I have the code of the framework because I'm using use visible task and use signals, because quick use signals. And use visible task is telling the browser that when the page is visible, you should have this JavaScript because the client should see the clock. But imagine that this clock is in the footer. Magic here. Where is my clock? Where is the JavaScript? When I will try to scroll, to go to the footer, he will download the JavaScript needed for it. Okay, so there is 2 things. When the user will interact with your page, it will go and execute the JavaScript needed for this interaction. And if this thing is, the user doesn't see the components in your page, we don't need to execute that. If you have a big page that contains a lot of JavaScript, why you should execute all of the JavaScript? And maybe the user will never go to the footer. So if he will never go to that, why you should execute it? It's very simple. When you're using Quick, it's built in the framework. Here, what you see with me, we are coding simple. We are not we don't intervene in the framework. It's the framework do that for us. Okay? So here, where I will scroll. Good, thank you. Thank you. So like I show you here, when I will scroll, I will have the JavaScript needed. I have another things here, okay? I have 5 minutes. Yes, great. Good. I don't need my clock now. What I will do, I will, what I need nothing. I will use signals now. I will create a simple signal, okay? I will call it count, use signal, true, great. And here, I will show this value of the signal. That's working fine, good. I show it, but I don't have JavaScript. And here, there is JavaScript. It's the signal, it needs JavaScript. But the framework understands that we will never modify this value. So why will download JavaScript needed for that? That's good. It's the framework understands that for us, which we don't need to tell him to do that for us. Okay, here I will create a simple button. I will call it add. Okay, and on each click, what I should do is I should add a value to it. Okay? So here I have no JavaScript. When I will click, I will get the JavaScript and the signal will work. That's good. Great. What I will have now, I will have another button. Okay? I will name it cancel expensive. Expensive. Okay? And here I will have an on click, and I will tell this on click what you should do. Okay? It should do a cancel log, but only if the count is more than 23. If it's more than 23, it should cancel log condition verified. Okay? So here I will click on my cancel expensive. I will get my JavaScript needed for that. I will not get the cancel because it's not more than 23. But if you see here, I will get this JavaScript. And I need this JavaScript now? No, I don't need it because the condition is not verified. It's very simple. Here we will use money. So what I will do is I will create a simple function. And I will use it like that. I will wrap it with dollars. Okay? It's a dollar sign. And here I will call my function. That's good. Now I have no JavaScript. And when I will click on cancel log, I will get the JavaScript because I clicked on the button, but I don't have the cancel log here. I have only a link that points to another JavaScript file that has the JavaScript needed for this condition. The framework here understands that the condition is not verified. So what he will do with using the dollar sign, we are telling the framework that we need lazy code execution. You know, you heard about lazy loading. Here it's not lazy loading, it's lazy execution of code. I tell the framework, execute this code when this condition is verified, and how? With a simple dollar sign. Okay? That's crazy, that's good. Now, imagine we have another thing. One day, I said maybe I have this cancel log is a lot of code, a lot of things that I should do, and I decided to refactor my code and to do all the code that I have in the front end in the back end. That will take a lot of time to do, okay? So here with using Quick, it's very, very simple. You will add only a server function, and when the user will have the 25, it will click on this button, and it will get the cancel log here. No, because Quick is using a server. Now I decided that this code will be executed in the server, not on the client side, and with magic, I will get it in the server. With only switching the dollar sign to a server function. Here I didn't show you that. When I had only the dollar sign, when I will click on network, I will get the code, and I will not get the file needed for this condition, for the cancel log. When I will add 24, if you see with me here, we will add, when I will click, I will get another file that contains the condition verified. So this is the lazy execution of code. And like I showed you, I have only 17 seconds, 15 seconds, 14 seconds, 13 seconds, 12, 11, 10. In less than 10, I can switch from the client to the server. That's crazy. Okay, you can see with me. I have nothing. I add, I click, I get it in the server. That's it. Thank you.
Amazing! Keep it going for Ayoub! Incroyable. Merci.